So good morning students, welcome to my channel again, Common Sense Explore. Today I'll explain about the properties of determinant. Okay, so please listen to me very carefully. First few properties, important property. Already I explained about the how to do determinant and their shortcut methods, right? So now I will explain about the properties of determinant. First of all, how the first property I am writing here. First property for a matrix. We want to calculate the determinant of a matrix, right? So now if first property, please remember, if two rows or two columns of a matrix are identical, then the determinant is 0. Two rows or two columns of an identical, that just see. So two rows means 1 2 3. Suppose I am writing 4 5 6 2 3. Okay, you can see here this is 3 cross 3 matrix, but you can see this row number 1 and row number 3 are same. So in that case, particular case, please remember determinant delta will be equals to 0. In that particular case, determinant will be equals to 0. Suppose 1 2 3 4 5 6 and again 4 5 6. You can see here also that two columns have identical or same equal, that means its determinant equals to 0. आँख बंद करके 0 हो जाएगा, ठीक है? This is the first property. Please remember the second property. We will go to the second property, and second property is saying that if two rows or columns of a matrix are interchanged, then determinant becomes negative. Two rows or columns. Second property, two rows or column can interchange, means suppose it was the matrix 4 5 1 3 0 1 and 2 2 2. This is a matrix. Okay, if two rows can interchange each other, means suppose this is row number 1 and row number 2. okay, whatever determinant is coming for this case, if you change the rows, that means suppose I am changing R2 with R1, that means if 3 0 1 will goes up and then 4 5 1 and then 2 2 2. In that case if you calculate the determinant, it will be negative, means if it is coming plus 5, suppose for example if it is coming plus 5, it will be coming minus 5, so it will be negative. Please remember, if you change any two rows or any two columns interchange, automatically determinant will be negative. And this is the second property. And third property is almost similar property. This, if you change three columns or three rows, then automatically that negative become positive again. Okay, that negative become positive again. Suppose I am writing here 1 2 3 4 5 6 7 8 9. okay, this is the determinant of is something, suppose x. okay, now first if you change row and column operation, means interchange, is this row is going in that side and this first row is going on that side. okay, in this way, so if you change 3 times, automatically what will happen, the determinant will be remain unchanged and will become positive. So 2 times interchange means it becomes negative, and 3 times means it is positive. Please remember, minus minus plus, 2 times means negative and 3 times means positive. So 2 times row column interchange, always determinant become negative, means if it is x, it will be minus x, and 3 times changing, if it is 3 times changes, so a determinant will be positive again. okay, this is the first, second, third property done. Now fourth property is the, if any column having the combined numbers, just see, for giving an example, if in the determinant of a matrix of any column containing the sum or difference of two elements, then it can be split into sum or difference of two determinants. okay, like this fourth property, if it is written as a b c square plus 1, suppose, then b c a square plus 1, then c a b square plus 1. Suppose this is the determinant. This determinant can be split into two parts, means this is the column where there is a combined, there two numbers. okay, two numbers, so it can be written like this: determinant of a b and c square, then b c a square, and then c a b square. This determinant plus this plus sign, again a b c square, a b 1 plus 1 is there, so a b 1 b c 1 b c 1 c a 1. Do you understand? So this particular determinant of this is nothing but determinant of this plus determinant of this, means addition, because it is only possible in case of column. If it is written in row, you cannot divide like this, you cannot split like this. okay, so splitting is only possible if it is written like in column. What is lower triangular and what is upper triangular? Lower triangular matrix, I am writing here lower triangular matrix, or you can say LTM. okay, lower triangular matrix means, suppose a matrix, particular matrix having principal diagonal in 1, lower 0 0 2 5 7 2 5 sorry 0 and 3 9 2 3 9 2. Okay, this is a matrix. How to know it is a lower triangular or upper triangular? Please remember, this is known as principal diagonal element. This is known as principal diagonal element. The upper portion of principal diagonal element, if it is 0, that means it is a lower triangular, that means lower value is only exist. This is forming a triangle, right? This is forming a triangle, right angle triangle. So this is known as lower triangular matrix. So upper triangular matrix is just opposite. Upper triangular matrix is just opposite. UTM I am writing. Okay, upper triangular matrix means, suppose principal diagonal elements 2 3 1 0 4 5 0 0 7. Can you see here? To try to understand, this is principal diagonal element, and upper portion of principal diagonal element is non-zero, but the lower portion is 0. So that means as upper portion is valid, so that's why the name is upper triangular matrix. Is that clear? So that means lower triangular means lower portion is valid, upper portion is 0. Upper triangular means upper portion is valid, means non-zero, and lower portion is 0. So this is how lower triangular and upper triangular matrix. For this kind of matrix, if this kind of matrix is given, you want to calculate the determinant. If you want to calculate the, suppose it is asking that calculate the determinant of this kind of matrix. How to calculate? Please remember, just multiplication or product of the principal diagonal element, means the diagonal you can do directly. Delta is equals to, delta means determinant, equals to 1 into 5 into 2. 1 into 5 into 2, that means 10 is the answer. For this case, similar way, 2 into 4 into 7. 2 into 4 into 7. This is the special case, please remember, for 56. Okay, 56. So this is how you have to solve for lower triangular and upper triangular matrix. This is a special case, please remember, this is a special case. For this type of matrix you can see directly and solve. Okay, next is the transpose of a matrix determinant of a matrix. Suppose a matrix is there, determinant of a matrix, and if you do the transpose of that matrix, their determinant is also same. Please remember this property also.